Today's lesson is a combination of three sections of big ideas, but they're all on the same idea, solving basic and multi-step inequalities. I included these all in one lesson because it's really the same thing, and if we know how to solve the multi-step inequalities, the basic come right along with it. And it's no different than solving an equation, except there's one giant difference, and that's going to be our focus of this lesson is what is the difference between an equation and an inequality. There's one core concept that we need to know. It happens when we multiply or divide an inequality by a negative. Now, other properties in algebra, like the addition property, subtraction, multiplication property, all of these work just the same as in an equation. I can add, subtract, multiply, or divide both sides of an equation by the same thing and get a new equivalent equation. Same goes for inequalities, except this difference with negatives. So let's take a look at these numbers right here. Negative 6 is less than negative 8. That's true. But watch what happens if I multiply both sides by negative 2. Negative 2 times negative 6 is positive 12. And negative 2 times 8 makes negative 16. And all of a sudden, 12 is not less than negative 16. The inequality must be reversed. And what's happening here, when we multiply or divide by a negative, all our positive numbers become negative, all our negative numbers become positive, and our number line switches in direction. So our inequality must switch as well. Now the same thing happens with division by a negative. In our example this time, 6 is greater than negative 8. When we divide both sides by negative 2, 6 divided by negative 2 is negative 3, and 8 divided by negative 2 is positive 4. Negative 3 is less than 4, and that inequality went from greater than to being less than. If we can keep this straight in our heads, solving inequalities is going to be a breeze. It's just like solving equations. Let's summarize. Solving an inequality is just like solving an equation, except when you multiply or divide by a negative. In that case, you must reverse the inequality. So a greater than becomes a less than. A less than or equal to becomes a greater than or equal to. Because what's happening when we multiply by a negative, the number line is flipping. Let's look at some examples. We're going to start with some basic examples. Basic meaning they have one operation to get the variable isolated. So in problem number 1, we have b minus 2 is greater than negative 9. I'll start by adding 2 to both sides. That gives us b is greater than negative 7. I'm going to graph this. I can do it very quickly. Let's go 0, negative 7. And we're going to use a hollow dot because it cannot equal negative 7. But it will be everything greater than it, so shade to the right. Number 2, m minus 3 is less than or equal to 5. Our first step to get m by itself, we'll add 3 to both sides. And we get the new equivalent inequality, m is less than or equal to 8. My inequality for this one, I'll go from 0 to positive 8. Shade from 8 and to the left, because it's less than or equal to, we'll use a solid dot on 8 and shade all the numbers less than 8 going to the left. Problem number 3, we have 1/4 is greater than y minus a fourth. To get rid of that minus a fourth, let's add a fourth to both sides. 1/4 plus 1/4 is 2/4, or 1/2. which is greater than y. It can be very tempting to just put a dot at a half and then shade to the right because it says greater than. However, that's not what it's saying. 1/2 is greater than y. 1/2 is the maximum. We can't go bigger than that. So really, this is saying y is less than a half. On my number line, I'm going to go, let's go 0, 1/2, 1. I'll use a hollow dot at 1/2 because it cannot equal a half, and shade to the left because these are numbers that are less than a half. They're also the number that a half is greater than. Problem number 4, same directions, more basic inequalities. However, this time we're seeing multiplication and division, and some of them are going to involve multiplying or dividing by a negative. Starting off in number 4, p divided by -4 is less than 7. We'll multiply both sides by -4 to get p by itself. And that leaves us with p. Now, because we're multiplying or dividing by a negative, p is greater than, and that inequality switches because multiplying by a negative switches the number line. So 7 times -4 is -28, and there's our solution. P is greater than -28. I'm going to make my interval go by, how about -7s? 1, 2, 3, 4. 4 -7s make -28. And we'll use a hollow dot shaded to the right. Problem number 5. X divided by -5 is less than or equal to -5. Our first step to undo division, we use multiplication. So I'm going to multiply both sides times -5. And when I do that, my inequality gets reversed. And it becomes greater than or equal to. On the left side of the inequality, my -5's cancel. We're just left with the variable x. And on the right side, -25 times -25 is positive 25. So our solution, x is greater than or equal to 25. Make my interval go by 5s. Solid dot because it can equal 25, and shade to the right because we're looking at numbers greater than 25, like 26, 27, and 28. Number 6, 1 is greater than or equal to -1/10 z. To get rid of times -1/10, I'll divide by -1/10, or simply multiply by its reciprocal, -10. Since I'm multiplying or dividing both sides by a negative, my number line flips, and so does my inequality. -10 times 1 is -10, and -1/10 z times -10, my two negatives make a positive. A tenth times 10 makes 1 z. So -10 is less than or equal to z, which is equivalent to saying z is greater than or equal to -10. Let's start on this side with -10. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Solid dot at -10, and we'll shade all of the numbers that -10 is less than, or that is greater than -10, which is all these numbers to the right. Problem number 7. Now these get into our multi-step inequalities. This time we won't just have one step to get to our solution. It will take a couple. So 4b minus 1 is less than 7. We're going to use the same steps we do in solving an algebraic equation. We'll start by getting the variable term 4b by itself using addition or subtraction. In this case, we want to get rid of a -1. We'll do that by adding 1. And my resulting equivalent inequality for B is less than 8. To get the variable B by itself, we'll get rid of times 4 by dividing both sides by 4. Because 4 is positive, no need to flip the number line, no need to flip our inequality, and we get our equivalent inequality B is less than 2. Which will give a hollow dot at 2 and shade to the left. Number 8. 8 minus 9c is greater than or equal to negative 28. Our first step will be to get that negative 9c by itself. We'll do that by getting rid of a positive 8. To get rid of it, we're just going to subtract it from both sides. That leaves us negative 9c is greater than or equal to negative 36. We'll get rid of the times negative 9 by dividing both sides by negative 9. Because we're multiplying or dividing by negative, our number line flips, so does our inequality. C is less than 4. Our graph will have a solid dot at 4 and be shaded to the left. And those are the multi-step inequalities. A circuit overloads at 1800 watts of electricity. You plug in a microwave oven that uses 1100 watts of electricity in the circuit. Write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. In our word problems, our first step is going to be to define our variable. What is it that's unknown that we're trying to solve for? And it's that last sentence that tells us write and solve an inequality that represents how many watts you can add to the circuit. So what we're going to do is first write a statement. I'm going to use the variable W because we're talking about watts. Let W represent the number of watts that can be added to the circuit. Now we're going to run an inequality using that information. We know the circuit overloads at 1800 watts. That tells us our total wattage has to be less than 1800. Because it overloads at 1800, we don't want it to overload. It can't be equal. We're just going to start by writing is less than 1800. Now we know we have a microwave that uses 1100 watts of electricity, and we want to know how much more can we add to that. Well, we can add W to that. So the left side of my inequality is just the microwave wattage plus how much watts is left to still be under 1800. And so there's our inequality. Finally, let's solve it. Simply to get W by itself, we're going to subtract 1100, and that leaves us with W, our wattage, remaining is less than 700 watts.